Hey, this is Andrew Brown from Exam Pro, and we're looking at certificates and TLS. So Kubernetes provides an API called Certificates Kubernetes IO, which lets you provision TLS certificates signed by certificate authorities, CAs, that you control. These CAs and certificates can be used by your workloads to establish trust. And even though, like in my 15-year career, I just never can remember what these things are. Like I know what they are, but I just mean like the specification and all the settings underneath. So if you find them like a little bit daunting or confusing, just understand that I've been doing it for a long time, and even I don't remember. So what is public key infrastructure? So PKI. So PKI is a set of rules, policies, hardware, software, procedures needed to create, manage, distribute, use, store, and revoke digital certificates and manage public key encryption. So it sounds like a very fancy system for managing public keys. What is X509 certificate? Because we hear this a lot in the web. It's a standard defined by the International Telecommunication Union, ITU, for public key certifications. If you've ever had to open up like an SSL certificate, I believe it follows the 509 standard here. So these certificates are used in many internet protocols. So as I said, SSL, TLS, and HTTPS, that's where you most commonly see it, or probably the first time you ever saw it if you've been in the cloud or web development for quite a few years. Signed and encrypted emails, code signing, or document signing. So like when you submit code to your repo, you can sign it to be like, yes, this code came from me. A certificate contains an identity, like a host name, organizational individual. So like who is the certificate we're signing on the behalf of? A public key. So these are algorithms like RSA, DSA, ECDA, and you can use a variety of different ones. So Kubernetes requires PKI for the following operations. Client certificates for the kubelet to authenticate to the API server, certificate for the API server endpoint, client certificates for administrators for the cluster to authenticate to the API server, client certificates for the API server to talk to kubelets, client certificates for the API server to talk to etcd, client certificates kubeconfig for the controller manager to talk to the API server. It's always talking to somebody here. Client certificate config for the scheduler to talk to the API server, client and server certificates for front proxies. Most of these are going to be stored in etc/Kubernetes PKI. It's going to vary for lightweight distributions like micro Kubernetes will place them somewhere else, Minikube will place them somewhere else. And when you create a cluster, generally it creates one for you, like a key, but there's actually a bunch of keys for a bunch of different things. We will come across this when we need to do RBAC, role-based access controls, because we will want to have a user and we'll have to generate a self-signing key, like we are the authority for it, and we'll have to sign it against keys from the cluster. And so that's going to be our exposure to this stuff. And I always find it kind of hard, but you know what? We do have to learn it, and it's not too bad, okay?